Good day, ladies and gentlemen. Now for our video, we have to show about the transistor circuit application. My name is Muhammad Adil and Abdul Azim bin Azmi and Shami Al Zubair. Here we're gonna talk about the history of a product that it changed a lot in electronics. First of all, we talk about the transistor, which is the FET, used for a variety of application as an amplified switching circuit. Is also now a device have in source transistor was invented by John Walter. Britton and William Shockley at Bell Labs in December 1947 announced to the public in this characteristics which code to of limitation of vacuum tubes. The commercial use of transistor increased dramatically in 1950s, beginning with the telephone switching equipment and military computers in 1952, hearing aids in 1953, and portable radio in 1954. Over 1 million transistors manufactured and transistors were manufactured, and by 1937 annual production had increased to 29,000 units. The rapid rise of transistor technology in the 1930s can be attributed to the contribution of a few major, including Bell Labs, Western Electronics, Fairchild, General Electric, Motorola, Philco, Raytheon, and so on. A transistor is a semiconductor device used to amplify or switch electronic signals and electrical power. It's composed of semiconductor materials, usually with at least three terminals of conduction of an external circuit. Here we can see the symbol of transistor, which is BJT and FET. But for our experiment, we are concentrating about FET. Here, after that, the theoretical explanation. FET circuits as shown below. FET circuits as shown in common fixed bias configuration, coupling capacitor Ci and C2 that isolates DC biasing from AC applicable signal to load. This circuit can be solved by using either mathematical or graphical approach. The volts drop cross RG permits replacing RG by short circuit equivalent. After that, when we come to the in the theoretical, we have to do the DC analysis and AC analysis. For the DC analysis, replaced by open circuit, and AC analysis. Oh, before that, we have to show the graphic of superposed and VG as a vertical line at VGS, VGG, the point where the two curves interest is the quotient of operating point. The AC equivalent circuit, as shown here. The fixed bias configuration includes coupling capacitor, which install the DC biasing arrangement from the applied signal, and they act short circuit. For ones of the RD small are from configuration, specification sheet, or characteristics. The AC equivalence model can be substituted between the appropriate terminals as shown above. If VGS is negative, the direction of curve source reverse. Current source reverse, sorry. The applied signal is represented by VI, and the output voltage across RD parallel with RD small by V naught. For the AC analysis, the coupling capacitor acts as short circuit for analysis. ZI, Z input, equal to RE because of the infinite input impedance at the input terminal of JFET, setting V naught as required by definition of Z naught, Z naught. So we'll establish VGS as OV also. The result of the GM VGS and the current source can V out RD parallel with RD small. Simulation. Then after that we come to the simulation for DC biasing, as was using the multism. As what we here can see, the DC analysis biasing and the multism. Then after that we have the result for it, which is the GM equal to 2 IDSS over VB, as what we know in our formula or our equation. We have for the input impedance, and we have for the output impedance Z naught, and we have for the voltage gain AV, all of it in the multism. Then after that we come to the discussion. The junction field effect transistor J fit over very high input impedance along with very low noise figure. This the higher low of the J fit to amplifier very weak signals, but measure to prevent oscillation the lower volts. The JFET is more expensive than conventional bipolar transistor, but buyer offer super overall performance. Unlike bipolar transistor, current can how through the drain and source in any direction equally. Often the drain and the source can be reversed in the circuit with almost no effect on circuit operation. In conclusion, for this assignment we were using fixed bias CS amplifier common source. As for transistor circuit application, we have to direct analysis on the alternating current. This problem of the circuit taught us a lot in understanding the common source circuit. For example, in direct current DC, the assignment on Also, in conclusion, this assignment was important because it could make us more prepared for an exam. Which exam?